about it.
I didn't say anything about it in my class either.
I think the Barbie is making me.
You got to make something up.
Oh, I didn't
Yep.
know if other classes.
Yep. It's all. If you look on that, if on your Barbie,
So it's just a
on your
YOLO.
Barbie rubric sheet.
It's recorded.
Okay. So on your Barbie rubric sheet, this is the stuff that we are expecting in that column 4. That's what we're expecting in column 4. Okay. So if you don't give us that, then plan accordingly. Okay. So it's all right. So the write-up and all that stuff, what we expect is all right there in the rubric. That's why we gave you the rubric. So.
Totally prepare your mind for
Yeah.
0 on everything.
So for next week Tuesday, for your next 4-mod day, 1, we want you to come to class with your exact number of rubber bands that you need to put on Barbie's bungee. Okay? And then hopefully your exact number for Barbie's bungee matches the rest of your group's exact for Barbie bungee. Filling up your patch.
Peace sign over here.
I know, I see that. Okay? So, and then if they're not exact, hopefully you guys can come to a conclusion as to what you want to go with for that. Okay? Also on Tuesday, you will need to bring your Chromebook. Okay? Because we are going to take what is called the EMPT exam on Tuesday. Okay? Fear not, the EMPT is not a graded exam. Okay? It is the early math placement test. Okay? Which is a placement test that UW-Madison and I believe some of the other state schools use to place their prospective students into the right math level. Okay? All right? So we're going to take that on Tuesday. Okay? That is a timed test. I don't remember how many questions it is. I think it's 40 questions, but I think you only get like 45 or 50 minutes to take it. And it's all online. Okay? So then they score it right away. You'll know your exact score when you come out of it. You'll know what level you would be placed at and all that stuff. Okay?
Would we have like something to write on for it?
You can use scratch paper and you can use a calculator. Okay. Yeah, but I think it's a regular calculator. I don't think it's a graphing calculator for that one. So, okay. But yeah, so that's on Tuesday. Nothing to be worried about for that one. Okay? Okay? Absolutely nothing to worry about going into that one. Okay? All right? So we've got that going on. Okay? The next unit that we are going to start is going to be something called conic sections. Now, conic sections, you've dealt with one of them very much in depth. Okay? And that's parabolas. Okay? You've done parabolas, but you've been limited to upwards opening parabolas and downwards opening parabolas. We're going to expand that knowledge into left and right opening parabolas too. Okay? See how I got my stretch in there too? PT right here in math. Okay, so you got that. And you've also dealt with a little bit with circles. Not a lot with circles, but a little bit with some circles. We're going to expand that knowledge on those two. Okay? The other two conics are ellipses and hyperbolas. Okay? And they're a little more involved, but again, we'll take the time, we'll go through them, we'll make it so that it's whoa! Okay? The fog will lift.
Oh, I was like, what is that noise?
The sun will shine down upon you, and it will be whoa! Okay? Alright? Now, an ellipse, you take that circle, so there's a circle right up there, and you grab onto either the left and the right side, or you grab onto the top and the bottom side, and you go, and you stretch it out just a little bit. That's an ellipse. It's a stretched out circle, either stretched out horizontally or stretched vertically. Okay? And then the hyperbola is a double parabola. Okay? Now, those are the very non-technical. It still is. That's a good thing. Okay? All right? So you need that to do that. Now that's the very untechnical terms. So let's hear the actual technical terms that go along with it. Oops, it didn't click on there. So there it is, and it's got a good baseline.
Circles, parabolas, and ellipses. Oh my.
We see them all the time, and we've even worked with them before in math class. But what are they really? How can they even be grouped together? 2 words. Conic sections. Conic sections. What is a conic section? What are they used for? How are they made? And where do they appear in the real world? We will look to answer all of these questions in our unit on conic sections. A conic section is created when a plane intersects 1 or 2 cones. What can result from this intersection is a circle when the plane is perpendicular to the axis and goes through one of the cones. An ellipse when the plane intersects one of the cones but is not perpendicular to the axis. A parabola when the plane intersects one of the cones but is not perpendicular to the axis. And a hyperbola when the plane intersects both of the cones. Depending on where the plane intersects with the cones, the size and shape of the conic can vary. See how the size changes as the plane moves around? Every type of conic, circle, ellipse, parabola, and hyperbola, has a specific equation that we will cover in the coming weeks. Once we master the basics of conics, we'll move on to the applications of conics. But what are conics even used for? The applications of conics are everywhere. Conics appear all around us, in architecture, in physics, in optics, in astronomy, and in navigation. For example, when you are lost and use a GPS to help you find out how to get home, the GPS uses conics to locate your position, the position of your home, and the distance between them. Another example is in architecture. Both bridges and buildings use conics as support systems. Mirrors and lenses are concaved in the shape of conics to focus light to a singular point, just like a lighthouse or a searchlight. Conics are also used to describe the orbits of planets, moons, asteroids, and satellites in our universe. In the coming weeks, we will master the basics of conics, learning the key terms and equations for each type of conic section. We will use the applications of conics to understand why conics are so important. And finally, we will end the unit by having every student create an image using the conics and equations we have learned in class.
Pretty sweet! Pretty sweet! Love
The
it!
only issue is that they use the word conics a lot, and I don't really know what that was.
Okay.
I didn't understand it. So that kind of
So, to start with conics, we need 2 key points, and you've already learned these 2 key points, or these 2 key concepts, I think is a better way to say than points, and that's distance and midpoint. Okay, so we need to refresh our memories on distance and midpoint and make it nice and easy. Okay, so this is the distance formula. You did it in chapter P. Okay, all right. So we had that in chapter P. We're good with that. Okay, now if we forget the distance formula, subtract the x's, square it, subtract the y's, square it, add them together and take the square root of it, we can always go with making a right triangle. Okay, we can always make a right triangle, and then we can use the Pythagorean theorem. Now, if I make this right triangle here, okay, then this bottom side, if I'm in a coordinate system, I would subtract the x's. So this would be x sub 2 minus x sub 1. And I would take x sub 2 first because it's bigger. Okay? So I would take x sub 2 and I would subtract off x sub 1. And up here, this would be y sub 2 minus y sub 1. Okay? And if I do that, now I can use Pythagorean theorem. This bottom side here squared, okay, that bottom side there squared, plus this side up here squared is going to be equal to, it's going to be equal to d squared. Okay? All right? And then I square root both sides to get what d is, and I get the distance formula. Okay? So we got that going on, which is great. Okay? So if we say find the distance between 2 points, subtract the x's, subtract the y's, square both of them, add them together, and take the square root. Okay? So it would look like, here's my old friend, the distance formula. X sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, and take the square root of that. Now, the nice thing about the distance formula is it doesn't matter which order you go with the points as long as you stay the same. So I could go negative 5 minus negative 3 quantity squared plus 1 minus 2 quantity squared, and take the square root of all of that. What's smeared?
You're a smart boy.
It looks
Oh.
like there's like a shadow, or like my eyes are just like jumping between.
They're like doubling.
Do you see that?
Yeah, I
You
know.
don't see the doubling? Like, look.
Maybe come back here, because
Yeah.
it's kind of weird.
Oh, now I see it. I see it up here. I see it up here in the distance.
Yeah, it's like everywhere.
Yeah.
It's numbers,
Yeah.
too.
Yeah, it happens. I'm over it. Okay.
It's just
So negative 5 minus negative 3 is negative 5 plus 3, which is negative 2. Negative 2 squared is 4. 1 minus 2 is negative 1. Negative 1 squared is 1. So I get the distance here is the square root of 5. And then I would simplify that radical if I needed to. The square root of 5 can't be simplified, so I'd leave it as the square root of 5. We're an exact type of class. We're not a, what is it, 2.2? 2.236. Okay? I don't want 2.236, I want the square root of 5. Okay? Try the second one. Now that song's stuck in my head. Or I should say that bass line is stuck in my head. So if I would go here, I would go negative 5 minus negative 3 quantity squared plus 0 minus 2 quantity squared. I'd take the square root of that. That's going to give me negative 2 in there. And that's going to give me negative 2 in there. And that's going to give me 4 plus 4, which is the square root of 8. And so my distance here would be 2 square roots of 2. Okay? Agree? Love it. Okay. Midpoint, we did some midpoint action in chapter P also. Okay. midpoint, average of the x's, average of the y's, and it's given to us as a point. Okay? It's given to us as a point, so we can handle it that way. Okay? Add the x's, divide by 2, add the y's, divide by 2, write it as an ordered pair. Love it, excited about it, should be all that I need to say about it. Find the midpoint of the segment joining those two together. So I take -2, I add it to 4, and then I divide it by 2, comma, 3 plus -2, and divide it by 2. Love it. Put it in parentheses because it's a point. -2 plus 4 is 2, divided by 2 is 1. 3 plus -2 is 1, divided by 2 is 1/2. So the midpoint is at the point 1, comma 1/2. Okay? All right? Not setting the world on fire with that. Okay? So let's talk circles now. Circles will be our first conic because it should take us all of 10 minutes to learn all about circles. Okay? The true definition of a circle is not that round thing that's sitting on the window. Okay? Right? Okay? Yes, circles are round. Get it. Love it. Excited to be part of that. But the true definition of a circle is the set of all points equidistant from a point. And that point we're going to call the center. Yeah. The equidistant part we're going to call the radius. So it's the set of all points equidistant from a point. So if I go over here, let's just say, let's use the clock because the clock is on the wall. So the center point is right here in the middle. Okay? And then the outer, this black edge here of the circle, if I put my finger anywhere on that circle, or on that black edge, okay, it will always be the same distance from my smartboard marker, or from my smartboard pen. Okay? All of these points are the same distance from that one. Okay? So the equation of a circle with center at the point h, comma k, and a radius r is this right here. The quantity x minus h squared plus the quantity y minus k squared is equal to r squared. That's the equation of a circle. Okay? So it has center h, comma k. So h is there. The x part of the center goes with the x of the equation. K is the y part of the center, goes with the y part in the equation, and radius r. Now, one thing that will be a common theme throughout all of these conic sections and throughout all of math is that if something is inside a parentheses, we have to think oppositely. Okay? If it's inside a set of parentheses, because inside this parentheses is x minus h. So if h is positive, it's going to look like, so like here in y minus 1, I'm thinking oppositely. It's minus 1 but really the k is positive 1. On the h, it's x plus 3, but really the h is negative 3 because x minus negative 3 becomes x plus 3. Okay. So the center down here on this first example would be at the point negative 3, comma, positive 1. I have to think oppositely on both of them. Okay. My radius is 2 because 4 is my radius squared. So that means my radius is just 2. So now to draw the graph, and for in your notes, because you're not using graph paper, if you just draw a sketch, that's fine. Okay? But I would go negative 3, positive 1. So there is my center point. Then from that center point, I would go up 2, right 2, down 2, and left 2. Now I got to draw a circle. I'm drawing the circles. Okay? How I draw my circles is I kind of flatten it out with a little curve at all 4 of those points, because then I just have to fill in a little bit there and it looks good. Okay? We won't take off for ugly looking circles because the bigger circles kind of get a little goofy. But in this particular situation, if you would have drawn this as a circle for that scenario, yes, we would take off for that because that's not where it needs to be. That's what it needs to look like. Something similar to this. If you want to use a compass, that's great. Okay, and then you'll have perfect circles every time. Okay? Sometimes you will have to get rid of coefficients before we can put it into the proper form. So if I divide everything by 7 there, I get x squared plus y squared equals 116. So that gives me a center at the origin and a radius of 4. How did I do it? 7 goes into 11 once with the remainder of 4. 7 goes into 42 6 times, so it's 16. Yeah. Okay?
Wait, so then you take the square root of 16
To get the radius, yep, because that's r squared. Okay? So then I would go out 4, 2, 4, 2, 4, 2, 4, and 2, 4. So then there's my circle. He's here today. Yep. Yep. Okay, so there's my circle. Okay? All right. Write the equation of a circle with the center there and the radius of that. Well, let's start with the general form. X minus h, quantity squared, y minus k, quantity squared, equals r squared. So this is just going to be x minus 3, quantity squared, plus y minus negative 2, that's plus 2, quantity squared, equals the square root of 5 squared. What's the square root of 5 squared? 5. So it's just equal to 5. Okay? If we gave you a problem like this, write the equation of the circle with the center there, and it goes through that point, the first thing that I would have to do is I would have to find that distance. 5 minus 2 quantity squared plus negative 4 minus negative 12 quantity squared. and then take the square root of that. So that's going to be 3 squared. That's going to be 8 squared. That's 9 plus 64. That's the square root of 73. So my radius, which is my distance between those 2 points, is the square root of 73. So this would be then, this is h, this is k, x minus 2 quantity squared plus y plus 4 quantity squared equals the square root of 73 squared, which is just 73. Okay? Good times. See, was that the foghorn to tell me class is done? Because class be done. Be gone. Remember Chromebooks on Tuesday, and Barbie, make sure you got Barbie ready to jump on Tuesday.